Imagine creating a music player app that's not just functional, but also visually stunning. How would you build a front end? What about the backend? In this video, we'll unravel the mystery and build our own full-stack app from scratch. We'll use React to bring our app to life and Java Spring to power it from inside out. Get ready to learn and have fun. Welcome back to Do Some Dev. My name is Gene. This video is largely based on another video with the title Full Stack Development with Spring Boot, from zero to hero. You probably came right from that video to this one. If not, you might want to check it out, as it covers all the non-technical basics of full stack development. Just like all the other Spring videos on my channel, you can find it in the playlist Spring Framework. Regarding this video, we will build a full stack application that consists of a front end in React and a back end in Java using the Spring Framework. The communication between them will be done using the RESTful API approach. For data storage, we will make use of a MySQL database and connect it to the backend. The entire full stack application will run on the same system and communicate over localhost. We will run the database in a Docker container, but this is just to make it easy. It doesn't really matter how the database is set up, as long as it's locally reachable. You can check out the code of this video on GitHub. Links to the repository are in the description of this video. Also, I would recommend to pause at the appropriate time in this video in order for you to try out things on your own computer. After having done so and understood what you need, come back here. You can listen to the same video part again to make sure you got everything you need. Also, any kind of feedback helps me a lot. I try to create these videos as best as I can, but I'm also just as human as you guys. We all are capable of making errors or seeing things differently. Write anything in your mind into the comment section of this video. Even just saying something positive provides me with a very welcome feedback. So the first thing we want to concentrate on is the backend of the full stack application. This is the part that will run on a server somewhere. It might as well be running locally, possibly also within a Docker container. It doesn't really matter. The essential part is that it serves our front end, which we will concentrate on later in this video. Our backend will be built using Java, but there's no good reason for us building it using only Java. Therefore, we make use of the Spring Framework, which is a fantastic library offering so much functionality, making our lives so much better. There is a quick start tool called Spring Initializer that helps us with a ready-made project we can build upon. And yes, Spring Initializer with a Z and an R at the end, not a typo. So let's take a quick look at what settings we want in Spring Initializer. The project we will set up will make use of Maven. You could just as well make use of Gradle. It really is up to you. Gradle and Maven are comparable tools. The programming language we will use is Java. But here again, it comes down to your own personal programming language choice. Therefore, it is up to you to choose between Java, Kotlin or Groovy. Now, we will have to choose a version of Spring Boot. We can choose between snapshot versions, a release candidate version, and a general availability version. Those general availability versions offer the highest stability. Hence, the choice goes to the version 3.3.5. Now let's take a look at the project metadata section. We change our group to our context, which is com_do_some_dev. Same for the artifact. Let's change that to full stack. The description can be set to backend Spring Boot example. The other fields, namely the name and the package name fields, are adapted automatically. Regarding the packaging, we choose jar and not the more traditional var. We also need to choose a certain Java version we built upon. I see no other reason as to take the newest, shiniest and prettiest version, which is currently version 23. We also need dependencies, but which ones would that be? For offering our RESTful web services, we will add the dependency Spring Web. Now we can make use of controller functionality, but we still need a way to store values in the database. Therefore, let's also add the dependency Spring Data.jpa. That's it. We now can generate and download a zip containing the entire project according to our settings. Now let's check it out. We have a class that runs the application. We can set certain application properties, and we also have the nvnw file that we can use to run this application. as well as the pom.xml file, which has all our project settings and dependency settings. We already have a default set of dependencies, but we need 2 further ones. The first is because we need to decide what kind of database it is we want to address, which is MySQL in our example. Of course, this could be any other relational database, like Oracle, SQL Server or PostgreSQL. Therefore, let's add the dependency for MySQL connector J. And what we are building here is an MP3 player, right? But how could we play an MP3 file from the backend application? Well, there is a library called VLCJ, which can do exactly what we need it to do. So let's make use of that and add it as a dependency. Now, for building and running the application, I think it is best to add run scripts. 1 bash script for Mac and Linux and 1 batch script for Windows. Same thing for the build scripts. 1 for Mac and Linux and another one for Windows. Okay, before we run the application, we also want to set up our database. Now, we could of course set it up locally, and if that's what you prefer, go ahead. Nobody's holding you back. Another possibility is to make use of Docker. I just love this approach because it is clean, concise and repeatable. Therefore, let's create a folder, Docker, in which we place run scripts. 1 for Mac and Linux and another one for Windows. Please make sure to adapt the directory settings according to your needs. It should be the same as the one that we set in the Docker compose file. I will show what entry in an instant. First, we need to address another matter. If we create something, we also want to have the possibility to remove it. Therefore, let's create ourselves a remove script. Same thing, please adapt the folders to be removed. Once the database runs, we may want to connect it over the command line. If so, we use MySQL to do so. Obviously, just like Docker, in order for this to work, it needs to be installed on the system. The last and most central file we require is the Docker compose YML. This file defines all the settings that our Docker container will have. Adapt the volumes to your needing. One thing we need to do before running anything is set the project's application settings accordingly, meaning the port the application runs on, as well as some database settings. Okay, let's run the Docker container for creating the database. We can check the Docker container by using this command, docker ps-a. Now let's run the backend using the run script we built. The last line should look like this one here, indicating that the application was run within a certain amount of seconds, which is 1.663 here. What we can do now is have a look at the main page of the backend. We haven't implemented anything yet, therefore we get this white label error page. But this is actually a good thing, because it means that we are running the application. Okay, now that we have everything set up, we can move our focus towards implementing our backend logic. Let's start with the data part. We have a playlist which essentially is a list of songs. Therefore, we add an entity class for that, which we call song. It consists of an ID, an artist name, a song name, and an MRL, which stands for Media Resource Locator, or in other words, the place where a certain media file is located on the system. The media file in this context is an MP3 audio file. If we want to add or retrieve something from the table song that is automatically created when running the application, due to the fact that we define the song class as an entity, we will need an according song repository class extending JPA repository. This is all we need for the data part of our application. We can therefore now move on and focus on building our service layer, meaning that we create a playlist service and annotate it with add service. The public methods we create in here will be accessible from the controller class that we will build in an instant. We start by having the song repository and the audio player component injected by Spring's dependency injection functionality. The audio player component is the one we will use for playing the MP3 audio files. The first method we want to implement is for getting a list of songs of the playlist. This means that we will first get all the songs from the song table, and then we will return them as a list of song response objects to the controller that called for this method. We will do this for decoupling the database logic from the logic of the controllers. The in-between place of the service classes is the perfect place for that. If in future releases of this application we decide to split the song entity into several parts, including the author, the genre, and so on, the part of the song response class remains unchanged, which is a big advantage. So let's create the song response class and add the list method to the player service class. Next, we need the functionality of adding a song to the playlist. This request will come in over the controller, originating from the frontend. The information will be everything that the song class has, except the ID. The reason for that is because we haven't yet inserted the song into the database. For the request, we need a new class handling the request structure. We name this class addSongRequest. Together with adding this class, we also add a new method to the player service named add. It will take the song and insert it into the song table in the database. Similarly, for removing a song, we will need a new class removeSongRequest, consisting of just an ID, which is the only information we need for removing an entry in the song table. We also add a new method named remove to the player service. Now we are getting near to implementing the method for playing pause and stopping an MP3 audio playback. But for doing that, we need to load the MP3 file first. This consists of the same step as selecting a song in a playlist. Coming from the selection in the front end, this again requires a class loadSongRequest consisting of the ID of the selected song. Within the player service, we add a new method load, which consists of getting the song entry from the song table according to its ID, and then passing on the MRL path to the media player from the audio player component. It just tells the player where the MP3 file is located. Now we are ready to implement the methods play, pause, and stop in the player service, all telling the media player the appropriate commands. That's it for the service part of the backend. Now let's implement the controller that has the role of providing a communication endpoint for the frontend. Therefore, let's add the new class playerController and annotate it with addRestController for defining it as a controller. Add request mapping with a parameter to tell the application that the controller reacts upon /API/player, and add cross-origin to allow communication from every location. The only thing we inject is the player service class. Now let's add the mapping for HTTP GET requests on /playlist, which adds itself to the end after /API/player. This method gets the playlist from the player service and sends it to the frontend. We add another method, addToPlaylist, with a HTTP post request mapping, making a call to the playerService.add method. Same thing for another method, removeFromPlaylist. Just like in the player service, we add another method, load, for playing a song, as well as for pausing and stopping a song. That's it for the backend. We have created everything we need. We can now run the application and start a set of tests using the application Postman, which is a popular API development tool for testing APIs. It really simplifies the API lifecycle, making it easy to create and consume APIs. Let's start by asking for the playlists. This responds with an empty list. So let's add a song using the URL, adding the header content type set with application/JSON, which is the way we communicate with the API. We also need to add a body according to the addSongRequest class, which had every information that the song class has, except the ID. After sending this information, the response should be 200 OK. We can now call the playlist again, and it should respond with a list and one entry. Because we know that the rest works, we will not test every controller mapping and continue to creating the frontend. We start by creating a new folder, frontend, and placing a couple of scripts for building, for running, and removing the web project, as well as setting it up. Once created, we execute the setup script to create a folder WebView using the Vite framework, containing a new empty React project with TypeScript support. We also add functionality from Material UI. So regarding Material UI, this is a popular React framework library that implements Google's material design system. It provides a set of pre-built, customizable UI components, such as buttons, cards, dialogues, and many more, making it easier to create visually appealing and consistent user interfaces for web applications in general. And also, because it is relatively easy to use once you get the hang of it, we will implement it in our MP3 player frontend. Using our run script, we can run the front end. We will also run the back end at the same time, separately in another terminal window. By calling localhost with a port 5173 in a browser, we can see the default page of our new front end project. We do not need to shut down the running front-end process during development. Once we place changes in the code, they will automatically trigger the front-end to update itself. This tremendously eases up the development process. Let's start by creating a new file, api-access.ts, to define all the functions we will use to access the API of the backend. We need one new function to get the base URL, which is localhost port 8080, because we want to avoid repeating ourselves every time we make a call to the backend. We will create another function called API-get, which only makes a call to a certain URL using HTTP-GET. It does not collect any response body. This is what we need the fetch API-get function for. It does essentially the same, with the difference of collecting a response body and returning it. We also want to create another function, call API-post, doing the same thing as call API-get, but with HTTP posts, which adds headers and a body in the request. Now we need a function for fetching the playlist. In order for the front-end to understand the structure of the songs, we need to define a new interface, song. The function for fetching the playlist is called fetchPlaylist. Now we create a function for adding a song, which sends an add song request, which we will need to define. The function is called addSong. For removing a song, we need a remove song request and the function making use of this remove song. For loading a song, we need a load song request, and the function for this is called load song. For playing, pausing, and stopping a song, we will need 3 according functions as well. That's it for the data part of the frontend. Now let's put the focus to the view part. We'll make use of React's class-based structure. So currently our front end consists only of the DoSomeDev logo and the title. What we want is an interface for the player. So let's create one and call it Player Interface. This interface takes 2 props. One for the controls like play, pause and stop, and one for the playlist. It arranges everything using a Material UI card. Now let's define the controls. So let's create a new class, Player Controls, defining a horizontal Material UI stack, holding a collection of Material UI floating action buttons. These are for playing, pausing and stopping an audio playback, as well as another button for changing into the mask for adding a new song to the playlist. When clicking on them, the according API function is called. What we also need is a Material UI table view for displaying the playlist. This is located in the playlist table class. It has functionality for showing the selected song, which corresponds to loading a song in the backend. The last class we need is the addSong class, which provides a couple of Material UI text fields held in a vertical Material UI stack. Now let's put it together in the app class, adding the player interface with its parameters. Okay, now we are done with the entire full stack application. Let's take a look at our new beautiful full stack MP3 player. Okay, let's put the application to a test. So this is the front end that we just built running in the browser. Here we have all the controls like play, pause and stop. And here we can add a new song. So let's do that. Let's start with an artist called Joe Crotty, with a song called Insiders. And the path to the file is this one. Add, and there we have it. We have a new song here. Let's add another one. The artist would be FSM Team. And the song would be Happy Days. And the path through the song is this one. Add. And here we have 2 songs now. Let's add a third one. So the third one would be Tube Baker. And the song would be Juice. And the path to the file would be this one. Add. Now we have 3 entries here. So let's play them. Let's click on the one that we want, Joe Crotty, and press play. And there we go. Sounds nice, doesn't it? But if we want to change that, we can change to FSM Team. Different style. Or we can change it to Tubaco to have something like a little bit more techno style. To sum up, we built an entire full-stack MP3 player application using React in the front end, Spring in the back end, and a MySQL database for storing information. All the codes used in this video can be found on GitHub. The link for that in the video description below. Also, make sure to like this video and subscribe to this channel if you haven't already done so. This is the best way to not miss out on future videos just like this one. Now, I'm sure you have already heard about microservices. Are you sure you know all the necessary details about it? What about mixing Spring into the context of microservices? I have a video about this in my playlist called Spring Framework, but you can also click here to directly access the video. So hop over there. See you in a minute.